So in the last couple of videos, we've figured out how to draw line structures of hydrocarbons, which we said are a really easy way of representing all the information that you need to in a format that's quick and easy to draw. We also classified these hydrocarbons. So in this video, we're going to learn how to name them. Okay, so in Gen Chem 1, you learned how to name things like CH4 or C2H6 based on just traditional nomenclature rules, right? So this would be carbon tetrahydride. This would be dicarbon hexahydride. Okay, but there are easier ways to name these things. Okay, these hydrocarbon chains all have common organic names. Okay, and we're going to go through the first 10. So one carbon, CH4, is methane. 2 carbons, C2H6, is ethane. 3 carbons, C3H8, is propane. 4 carbons, C4H10, is butane. Adding a 5th carbon, so C5H12, gives us pentane. 6 carbons, C6H14, gives us hexane. 7 carbons, which is C7H16, is heptane. 8, C8H18, is octane. 9, which is C9H20, is nonane. And finally, adding a 10th carbon, we have C10H22. This is decane. So hopefully what you'll note here is these names all end in ane. Right? So an ending of ane means an alkane. So all of these are saturated hydrocarbons. Ethane is C2. Propane, a saturated 3-carbon chain. Butane, a saturated 4-carbon chain. Pentane is a saturated 5-carbon chain. Hexanes, we're adding a 6th. Heptane, we're adding a 7th. Right? And on and on. Adding a double bond complicates things a little bit, but not really all that much. Okay, so let's look at butane, but let's go ahead and add a double bond to it. Okay, so the one thing you have to be really careful of when you're naming alkenes and alkynes is you have to somehow imply the position of the double bond. Okay, so this is carbon number 1, carbon 2, carbon 3, and carbon 4. Okay, so it's not enough to just name this butene, right? Having a suffix of "ene" means an alkene, so it means there's a double bond. It's not enough to just say butene. You have to imply the position of the double bond. So this double bond starts at the first carbon, it goes to the second carbon. So this is 1-butene. Okay? The double bond is present on the first carbon and the second carbon, but the number we give it is always the lowest number possible. Okay, let's think about a similar compound. So if we put the double bond between the second and third carbon, so this is still butene, but in this case I number 1, 2, 3, 4. So in this case, the double bond is between the second and third carbon, so 2 is the lowest number, so we give it 2-butene. Okay, so what happens if we move the double bond to the very last bond? So in this case, if I keep with my numbering scheme, I have 1, 2, 3, 4. So based on what we've talked about so far, we would name this 3-butene. But as it turns out, this is incorrect. Okay, so this is not correct. And the reason this is not correct is that this numbering scheme is not correct. The reason it's not correct is because we can also start numbering this from the right side. So we could number this 1, 2, 3, 4, making this 1 butene. Okay, so we always name it so that the number is the smallest number possible. So as it turns out, this compound is identical to this compound. There is chemically no difference. Right? If you were to rotate one butene clockwise, you would end up with this compound. Okay? Let's try one more alkene. So let's draw. Okay, so first things first, let's figure out how many carbons we have. We have 1, 2, 3, 4, 5, 6, 7 carbons. So this is a heptane base, but it's a double bond, so heptene. Now the question is, how do we number it? As we've drawn it, we would call it 4-heptene. But let's start from the other direction and see if we can come up with a smaller number. Okay, so if we started numbering from the right side, it would be 1, 2, 3, 4, 5, 6, 7. So 3 is smaller than 4, so the correct name for this would be 3-heptene. All right, and these rules, these same rules apply for alkynes. So if we draw out this compound, okay, I have 1, 2, 3, 4, 5, 6 carbons. So my base structure is 6 carbons, so that's hexane. But it's not ane because we have a triple bond, so this becomes hexyne. Okay? And the last thing we need to do is figure out if 2-hexyne is the best name for it. Let's number it from the other direction. 1, 2, 3, 4, 5, 6. So in white here we have 2-hexyne, but in yellow we have 4-hexyne. So 2-hexyne is the correct name, right? 2 is less than 4. So this compound is 2-hexyne. Okay, so this is how we name our alkanes, alkenes, and alkynes. In the next video, we're going to explore how we can name these hydrocarbon chains that have been functionalized with something else.